Okay, Mad Dog Shy brings up a good point. She says that the half angles are seen right under double angle ones, and that is absolutely true in your notes here. It's also true on your sheet of notes right here. All of the half angles sit right below the double angles. So whichever one you use to write down is fine. If you want to copy them off here, there you go. But we just used the formulas that we had yesterday, and we can solve for what we refer to as half angle formulas. I see everybody writing. Looks like most people are getting towards tangent. Tangent of an angle divided by 2, you have two options. You can either use 1 minus cosine of A over sine of A, or you could use sine of A over 1 plus cosine of A. I starred the one that I like to use. I like to use the first one. Some people actually set up both on the test, and they cross multiply and solve, and they wonder why they come up with 1. Well, you come up with 1 because they're equal to each other. Don't set up both of them. Just set up one of them. You get a choice. It's a beautiful thing. You get to choose what you want to do. I like the first one better because if you're looking for sine of an angle, you might get 1/2 or the root of 3 over 2. But if you do 1 plus, then let's say you get 1 plus the root of 3 over 2, then you got to multiply by the conjugate, 1 minus the root of 3 over 2. I'm going to simplify it. And that, so I like to keep the denominator as simple as possible. Does that answer your question, Sam? Okay, so let's look at a problem that you technically already know how to do, but we're going to do it a different way. Cosine of 15 degrees. You did this problem the other day. You did cosine of 45 minus 30, right? Well, there's another way to do it. I could view 15 as an angle that's half of another angle. Cosine of 15, 15 is half of what? So 30 over 2. So I'm going to use my half angle formula. And half angle formula says it's the square root of, plus or minus the square root of, 1 plus the cosine of the angle, all divided by 2. Now, first of all, this is the most important part. What goes in for A? That's the question you have to identify. Look at the problem. It says cosine of an angle divided by 2. What angle are we dividing by 2? 30. So that's what you put in for A. You put in 30. See that? Some people put in 15. Don't do that. Put in the angle that you're dividing by 2. Second of all, plus or minus. You have to determine whether it's positive or negative. Let's think about it. Cosine of 15 degrees. Which quadrant are you in for 15 degrees? First quadrant, so is cosine going to be positive or negative? Positive. So we have the square root of 1 plus the cosine of 30 degrees over 2. Well, what's the cosine of 30 degrees? Think about your triangle. Get nothing, YouTube. You got 1. Yep, root of 3 over 2. Very good. Cosine is the x value. Got root of 3 over 2. So now I've got the square root of 1 plus the root of 3 over 2 all over 2. That makes you somewhat uncomfortable inside because you have this square root of a square root. Actually, in mathematics, we don't really worry about the square root of a square root. There's not much you can really do about it. In fact, there's a study built off that called complex radicals. But what we are concerned about is that we have a complex fraction here. You can't have the fraction within the fraction, so we're going to simplify that. So how do I create one fraction in the numerator? Common denominators. So would you agree that would be 2 plus the root of 3 over 2? All over 2 over 1. Okay with that step? Okay. Now I multiply by reciprocal 1 over 2. And I get the square root of 2 plus the root of 3 all over 4. Can't really do anything with the top, can you? But can you take the square root of the bottom? You sure can. And you get the square root of 2 plus the root of 3 all over 2. We good? It would not be plus or minus. We know it's positive because you are in the first quadrant. See, yesterday we didn't know which quadrant we ended up in, did we? So, I mean, we really had to pay attention to plus and minuses. Here you can determine ahead of time. Now, just for effect, I want to let you know, the other day when you guys did this, you guys got the square root of 6 plus the square root of 2 all over 4. Remember coming up with answers like that? We said the cosine of 15 was equal to that. Well, if you type those into your calculator, look, I have them typed in right there, and we get 0.9659 for both of them. Turns out that those two things are equal to each other. Okay, cool. Letter B, sine of pi over 8. What do you need to do first? Get it to degrees. Well, pi is 180, so pi over 2 is 90, so pi over 4 is 45. So pi over 8 would be 22.5. So this is sine of 22.5 degrees. Now, you're kind of frustrated right now because you're like, Mr. Gantz, you just gave us a formula for half angles. We could have just used sum and difference. You just taught us something that's pointless. No, I didn't, because here we don't have any two angles that are going to add or subtract 22.5, do we? So we need to use a half angle formula. So this is going to be the sine of something divided by 2. What is that something divided by 2? 45 over 2. Boy, I wish I had a handy-dandy half-angle formula to use. Oh, great, we do. Wonderful. Wish I had a nice sheet where they're all written out for me. Wait a minute, I do. Somebody does care about me. Everybody here knows what the cosine of 45 is. What is it? Root of 2 over 2. Is it going to be positive or negative? Positive, first quadrant, good. 1 minus root of 2 over 2 all over 2. Too many 2's. Too many 2's. Okay. So that was Sidney Collins' joke from first hour. Yeah, they were awake. Hey, this class is very exciting. Nobody ever sleeps. Right, Alexis? Okay. Hey, stop it. Okay, zombie-like state. Yes. Zane is asleep. Dane is a sleeper. That's true. Okay. So I get, when I find common denominators, 2 minus the root of 2 over 2, all over 2 over 1. Now what? Multiply by the reciprocal, so multiply by 1 over 2. A lot of people think that the 2's are going to cancel. They don't. You get the square root of 2 minus the root of 2 all over 4. Square root of 4 is 2, so we get the root of 2 minus the root of 2 all over 2. Too many 2's. Ha, ha, ha. Very good. We pause the video. You're going to practice. Okay. Last set of formulas that you want to learn are your sum to product and product to sum formulas. They allow us to take something that's written as a product and write it as a sum, or something that's written as a sum and write it as a product. We're not going to write all of these out because there's 8 of them, and they all start to look the same, and it's going to be pointless for us to do. But what we are going to do is locate them. Look, sine of A times cosine of B. I look at my sheet, which you guys have, and you have sine of A times cosine of B. It's this one right here, and this is what I would write in its place. Wow. Nice. Good job. Everybody see that? There it is. Look at your next one. Your next one says, if you want to go sum, so sine plus sine. Again, I look on that sheet. I just look at the space above it. I look for sine plus sine, and this is what I get. Everybody know where to grab your formulas? Let's show you how to use them and how simple they are. says write the following product as a sum. Sine of 4x times cosine of 2x. First thing I do is I grab my handy-dandy formula. Sine times cosine, it looks like we got 1/2 sine sine. I'm going to write that out. 1/2 times sine of a plus b plus sine of a minus b. Everybody got that? So, in this problem, what's A? 4x. What's B? So I have 1/2 times the sine of what's 4x plus 2x? 6x. Plus the sine of what's 4x minus 2x? 2x. Done. That's it. That's it. Look, it says write the product as a sum. This is a sum now, right? Yeah, I guess if you want to raise 1/2 sine of 6x plus 1/2 sine of 2x, you could, but now it's written as a sum. You might be wondering, why is that useful at all? I had 3 students who were working through some calculus 2 today, and one of them sitting out there right now, Mr. Ware, and he actually needed to. You remember how yesterday we took cosine to the 4th of x, and we wrote as cosine squared times cosine squared, and you worked that whole thing out. They were doing a problem. That's the problem they had today. They had the integral of cosine of 4th dx. You can't do that problem. You have to rewrite it out. So they had like 3 problems that were all exactly the stuff that we're doing in college trigonometry. And I quick show them, they're like, oh yeah, I remember that now. Oh yeah, I remember that now. So your ability to keep some of these things not necessarily in your mind, but just know that they're on a sheet of paper, know you're able to do them once before. That will give you the confidence when you encounter them again, you'll be able to work through it. Trust me. Okay. All right. The next one, 3 cosine cosine. I look at my sheet. Cosine times cosine. I've got let's say cosine plus cosine. So we're going to go 1/2 cosine of a minus b plus cosine of a plus b. Now, what's different about this problem is I have a 3 out front. So instead of 1/2, what do you think is going to be my constant? 3/2 times the cosine of what's a minus b? Negative x plus the cosine of what's a plus b? 3x. Am I done? Nope. Make me proud, folks. Ishka, louder. Very good. You can't leave a negative angle. So, cosine of a negative, do you remember what happens to negative for cosine? Disappears. So you end up with 3/2 times the cosine of x plus the cosine of 3x. That's because cosine is what we call an even function, so the cosine of a negative is the same as cosine of a positive. Not too bad, huh? What if we had to do sums to products? Sine minus sine. I look at my sheet. Sine minus sine. Looks like I got 2 cosine sine. 2 cosine sine. 2 cosine of a plus b over 2 times sine of a minus b over 2. Can somebody verify I wrote it down correctly? Good. All right, what's a plus b? 4x divided by 2. So 2 cosine of 2x times the sine of x. That's it. Pretty straightforward, huh? Last 2 examples. Find the value of the product or sum. Here we're given actual angles. 3 sine of 105, sine of 15. You don't know the exact value of sine of 15 or sine of 105, do you? Nope, we don't. But maybe if we switch it instead of a product, maybe if we switch it to a sum, maybe it'll work out for us. So if you look at your sum formula that you have, or your product to sum formula here, sine times sine, it gives us, let's see, cosine minus cosine. So I end up with 1/2 times cosine of a minus b plus cosine of a plus b. I had that wrong, don't I? It's a minus in the middle, isn't it? Sorry about that. I'm not perfect, everybody. Stop yelling at me. YouTube thinks you guys are just restless crew that just swears at their teacher. Yeah. All right, here we go. What's a minus b? 90. And I have to multiply it by 3, so I have 3/2 times the cosine of 90 minus, what's a plus b? 120. So cosine of 120. Can somebody tell me what's the exact value of cosine of 90 degrees? 0. Nice job. There are 2 times times 0 minus cosine of 120. Negative 1/2. So it'll be plus 1/2. 0 plus 1/2 is 1/2. Times 3/2 is 3/4. What do you think about that, Emma? Last example. Do you know the exact value of cosine 75? Cosine 15? Maybe one of our formulas will help us. We have cosine minus cosine. We got to use -2 sine sine. -2 sine sine. -2 sine of a plus b over 2 times sine of a minus b over 2. Get somebody to check and verify that, see I have it correct. Thank you. That's Spanish. Yes. Oui, oui. 2 times the sine of, what is a plus b divided by 2? 45. Nice work. Sine of, what is a minus b? 30 divided by 2? 60 divided by 2? You're just smarter than all of us, Willie. Stinking genius. -2 times sine of 45? Yeah, they're both. Yeah, that's sine of 30? 2 times 1/2 goes away. You're at 2 over 2. You guys, you have to. I just want you for a second to appreciate what I see. You have to understand that I used to give everybody. Do you have that sheet? The unicircle one. So I used to give everybody this piece right here. And so as soon as I would say, what's the sine of 30, everybody would go to this sheet and they'd look it up. And I realized nobody knew what the sine of 30 was. Right now I ask you the sine of 30, and everybody's able to come up with it. In fact, some people come up with it so quickly that it upsets other people who are trying to get through it. And that's very satisfying for me that you guys are able to work through that. So that's movement in the right direction. So nice job. Great work.